Ideal gas law. So let's go over with all three laws that we learned. We know that V equals KT, and that's constant pressure and number of the moles of gas, right? We know that V equals Kn, constant T and P, Avogadro's law. V equals K divided by P. Constant we have T and N. All three laws, right? Boyle's law, Avogadro's law, Charles' law. Then all three, when we bring all three together, you come up with one, which is PV equals nRT. That's the ideal gas law. Okay? So, in that, this is, we know, pressure. This is volume. This is number of moles of gases. This is gas constant, which is 0.082 liter atmosphere mole Kelvin. It's a gas law constant, gas constant. And T is a temperature. And that is ideal gas law. PV equals nRT. PV equals nRT and R is constant, which is always 0.08206. Now we are going to apply this law into one of the problems. Yes?
So, what is KV?
Constant. In this one, these are constant. Alright? And then this is also a constant. Okay? Now let's work on one of the problems. An automobile tires at 23 degrees Celsius with an internal volume of 25 liter is filled with air to a total pressure of 3.18 atmosphere. Determine the number of moles of air in the tire. Alright. So in this one, we have temperature T is given, volume is given, and pressure is given. We need to find out number of the moles. Okay? We know the equation. We are going to use PV equals nRT. When we rearrange for n, PV divided by RT. Okay? Alright. Now remember, temperature should be in Kelvin, so 23 degrees Celsius plus 273. So you convert into Kelvin, 296 Kelvin. Okay. Now plug it in here. So you have 3.18 atmosphere, volume is 25 liter, R is 0.082, and the temperature we have 296 Kelvin. Okay, and we are trying to solve the problem for number of the moles of gases. When you calculate, you get 3.27 mole. That's the number of the moles of gases for this particular problem. Okay, we are going to work on a few more problems. Okay. Next one is what is the pressure in 304.0 liter tank that contains 5.670 kg of helium at 25 degrees Celsius. First, what we need to do, convert kg, convert kg of helium into moles of helium. So that we need to do first. So we have 5.670 kilogram. So we convert into grams first. And then formula mass of helium 4.003. So that's how you convert moles of helium. Okay. And then we know PV equals nRT. We need to find out pressure, nRT divided by V. Okay. And then we plug the values in it. What do you guys find for number of the moles of helium? Go ahead and let me know. And we can plug that one. R value is 0.082. Temperature is 25 degrees Celsius. So you can always convert 298 Kelvin. Volume is 304.0 liter. Now what do you get for moles of helium?
1,416.
What?
1,416.
1,416? 0.44. Is that right? Okay. So you plug that one here. Moles of helium. And when you calculate, you get 114 atmosphere. So that way you can apply and calculate pressure.
Where did you get 4.003?
That's the mass using periodic table, atomic mass of helium. And that's how we convert moles, grams to moles, right? Divided by its molar mass, formula mass. Okay. Now we are going to work on one more problem. Okay. At what temperature in degrees Celsius does 121 milliliter of CO2 at 27 degrees Celsius and 1.05 atmosphere occupy a volume of 293 milliliter at a pressure of 1.40 atmosphere. Now we have PV equals nRT, right? Now we have volume, this is our volume, alright. Now we have temperature, we need to find out degrees Celsius, this is a pressure and that's the temperature, okay. Now in this one we can write for one condition P1, V1 and T1. This is we need to find out V2 and P2, we need to find out T2. So this is for just one, but when you have for two conditions we can write P1 V1 over T1 equals P2 V2 over T2. These equations we are going to write for that, and in this case we need to find out T2. Okay, so again what we do first, cross multiplying, so you get P1 V1 T2 P2 V2 T1. We need to find out T2, so we need to separate P2 V2 T1 divide by P1 and V1. Now again it's so easy to convert it, right? Now once we reorganize and everything, I'm going to plug the value here. P2 we have 1.40 atmosphere. V2 we have 293 milliliter. And T1 we have 27 plus 273, so which is about 300 Kelvin. Okay. And P1 1.05 atmosphere. And V1 which is 121 milliliter. When you plug those values, you get 696 degrees Celsius. Yes, you convert into Kelvin. You find into Kelvin and then you convert into degree Celsius. So that's where you get 696 degrees Celsius. You find in Kelvin and then convert into degree Celsius.